Welcome back to our presentation and our course. Today it's the insulation day, and I will change something because we have a lot of slides, we have a lot of written stuff and pictures. So I will remove myself from the screen today, and so you have to be without my face for approximately 10 minutes. So I hope it's not a problem. So let's get started. I hope I removed myself, and let's go for the presentation. I'm just okay. So insulation it is. So insulation materials for wall retrofitting. So we have several different kind of materials available. So here, for example, you can see the density. Then you can see the thermal conductivity, which we already discussed. And then we did not discuss the vapor and the Q value. This is actually how the material responds to moisture. So as higher the value is here, as it is kind of a closed cell product, and you can use it outside, so it's not absorbing moisture. So I think interesting is here the value of the thermal conductivity, and you see the different values here, and which is like the best one is here the evacuated silicate board, which you sometimes use actually inside to save space. So it's a vacuum insulation. And then how to put to bring them into the building. So you have different ways. So I just want to show you briefly that one because it's between the outside insulation and the inside insulation. It's like in between, as I said. So you can blow it like this guy is doing on the under the roof, or you can fill up this one. So you just fill in these roof there, or you can blow it into the cavity wall like this guy is doing. So you drill holes and then you fill that in. What you can use for that is celluloses, fiberglass fibers, and styrofoam pellets for this kind of blow-in insulation. But let's focus on what is the advantages and disadvantages of the outer insulation. Here it's seen in yellow, and here also the inner insulation. So in a nutshell, you can say the advantages is actually protection of a massive wall, thermal bridge minimization. That's actually quite important one. Condensation risk reduced, also very important for Mongolia environment. No influence on room size, so you can use all the size given inside the building. Thermal mass can be used. Thermal wall mass can be used. It's also important. More expensive than inner insulation, yeah, it is. And you have a problem if you have old buildings and decorated facades. I mean, with old buildings, really old one with a nice facade. So from the inner insulation, the advantages are lower costs than outer insulation. Phased implementation possible, so you can go for one room after the other depending on your money available or space, moving one things to the other one in the room. No change on outer facade. This is critical here. The higher risk of condensation, higher risk of building damage due to condensation most of the time, and moisture entering the frame, particularly on wooden frame buildings. Higher wall temperature difference, and then thermal bridges problems. Yes, that's we have here as an advantage, and room size is shrinking. So let's go on the outer insulation. So how it is done, so that we have different versions. One I showed already a bit. Here we have the wall, then we have this aluminium sub construction. You have the insulation in between, and then you have a kind of cladding there. So this one most of the time is mineral wool because of the better flexibility of insulation, and it's a little bit a costly solution, but you can actually make a nice facade on your building. However, and that I think is critical here also, your thermal bridges problems, especially when using metallic substructures, particularly this one. So you're really getting here, you bridge the insulation here. So what is the purpose of it? Well, you have you have the wall, you have the insulation, then you have this substructure. So what you need is actually an opening. So ventilation openings for 50 centimeter, and you need up behind an ventilation of approximately 20 millimeter. This is actually then protecting the wall, and so there are different ways how to do that. So here we have, for example, a different material used. Here it's just gluing it. Here same, just gluing it, a very thick insulation. So here they have a insulation composite system, and that's that one here, and I want to show you that on a little bit on the next slide. So outer insulation system for exterior wall here, you have different layers to protect the wall and have a good insulation. Construction layers are similar for other insulation materials, so it's depending. You can see them on you have to look at the market there, but of course these are commercial pictures there. So how to fix it on the wall? So one way is actually to glue it, which could be okay if it's done in the right way, or you can actually, for example, nail them, or you can screw block them. So both ways are used. That's how they look. These are the screws here, and then the nails. And I want to also to show you what could be done wrong. So here, for example, outer insulation system for exterior walls, consequence of incorrect fixing. So here the whole insulation went down. Not sure what was the cause. Also here, so these are pictures which I got from my colleagues from integration, and it seems like for me that they're just glued, and maybe the combination of the glue was not right, or moisture came in between. Not sure of that, but you see the whole wall came, the whole insulation came here down here and also here. So let me see. I have 15 slides and 8 minutes. Okay. There's another way which insulation can be put on the building. That is the PU spray form. It's a lightweight and quick way to improve insulation quality, but it has to be conducted carefully. There is a reason why this man is covered like during Corona at times when you measure other people's blood or like in the hospital. This stuff is not. It's also a little bit unhealthy, I would say. And if you just put it outside on the building and all this gassing is gone, I think it's not a problem, to my opinion. However, if you're more interested in that, have a look at this link here. They will talk a little bit about, because you also can use that inside the building, and this gassing might be not really what you want in the building there. So this is a quick way of insulation, but it should be considered carefully. Then we have another one here. You can see you just the insulation on the top of the ceiling of the top floor. So On the top you have the roof, and then you just put an insulation layer here. As you can see, upsala, that was too quick. This is used as a mineral boards and topmost ceiling at the German retrofit project, blah, blah, blah. Ventilated flat roof. That's what I actually was looking for, ventilated flat roof. So this is one version where you can actually change your U value from the roof from 0.81 to 0.16, which is actually quite good. And then you have inner insulations, and I hope I still can. I think I have to stop here and bring it. Well, 2 more slides. I will stop on that one here. Let's see how that works here. Basic system types. So we have the massive wall, we have the inner insulation, we have the vapor barrier, and then we have a cover of gypsum board or something like that. So inner insulation with vapor barrier on the warm side of the insulation, so as to avoid condensation with the wall. On the other hand, if you don't want to use the vapor barrier, there are other ways. So inner insulation, not diffusion resistant, so it means that the moisture can actually enter the wall, but it's breathable. So this is also an option for the inner insulation. And there are different kind of products here. So mineral foam board, open to diffusion, that was the second option. And then here you have the gypsum EPS sandwich board with an integrated vapor barrier. So these are the two options which I just showed you. So it's integrated, the vapor barrier is integrated in that one. However, on the last slide, I want to show you the problems. Major disadvantages in the Mongolian climate if you do the insulation inside the building, so inner insulation. Thermal bridges cause unwanted heat losses and in worst cases condensate on inner surfaces. As I mentioned in one of the first slides, inner insulation is very difficult to get rid of thermal bridges. On the other side, not on the other side, but also a shortcoming is if you have moisture in the wall coming up here and you have the -30, for example, here, you can actually freeze the moisture particles in the outer wall, and that could lead really to damage of the wall. So freezing humidity within the massive wall cause outer surface spalling, so pieces can fall off. Okay, that's so much to the insulation. There will be a little bit more on the edge presentation. Thank you for listening.